Good afternoon. This is Professor Arnold, and today we're going to talk about confidence interval for estimating a population mean with alpha not known. We will do this by an example. So very quickly, let's see what the example says. The example says the mean of a certain sample of 50 subjects from a normal distribution is 22, with a standard deviation of 2.5. All requirements for a confidence interval are met. Construct a 95% confidence interval. Now, the requirements are met is just so that we don't get bogged down talking about the requirements. We just want to find out how to mathematically compute the confidence interval. So, methods. We have a couple methods that we can use to do this. These are not the only methods, just these two is the ones that I'm going to cover. You can find the standard error, the critical t-value, and the margin of error. That's the first method. And the second method is simply to use the TI-84 calculator function, t-interval. So let's look at method one. Just a reminder, we are constructing a 95% confidence interval. And this time we have 7 steps for method one. First, we check the conditions. Like I said, we're not going to dwell too much. The first one is the sample is a simple sample. And the second is that it's from a normal model or n is greater than 30. So since the example told us that the conditions are met, we know that these two things are met, so we don't have to go into any details on those. Now let's go in. So the next step is to draw a picture. So we're going to draw a picture. So here we go. Here is my normal curve, best I can do on the slide. And I'm going to draw some lines here. So a line down the middle and 2 to separate the alpha values. And so you know, in the middle, centrally located is 1 minus alpha, and that is the confidence level. So in this particular case, the confidence level is 95%. So 1 minus alpha is 0.95. 1 minus alpha is 0.95. Okay, so from that, you can calculate what alpha is. So in any normal curve, in this case, it's a t distribution, you see that you can have the t star on the t-axis. You can have 2 axes is what I was trying to say. So one axis is the x-axis, or the x values, or the data values. And here I show you where the left endpoint and where the right endpoint is relative to the center. In other words, the center is where x bar is. So we're going to find t star based on alpha over 2. And once you find t star and you find the standard error, you can also find RE and LE. Okay? So some people use X1 and X2 instead of LE and RE, but they're all the same thing. I am only mentioning it because you might look at another book, or you may look at another book and you see a different notation and you want to know, well, which one is correct? They're both correct. It's just different people use different notation. Okay. So the next step is to compute or determine X bar and the standard deviation, Sx. So I say compute or determine because in this instance, we don't have to find it, so we just determine it. So it's X bar is given and the standard deviation is given. But sometimes they will give you a bunch of values and then as the sample values, and you have to find X bar and SX. It's not a big deal. All you do is use your calculator, use the column L1, put that in there, and use the corresponding functions to find the mean and standard deviation. Okay, in this discussion, whenever I say calculator, I'm referring to the TI-84. You may use a TI-83, but you may also run into a problem every once in a while that it doesn't have one of the functions that I may mention. I think for this procedure, I think you'll be okay to use a TI-83. I don't think I'm using any of the functions that's not on the TI-83 as well. But to be on the safe side, you should have a TI-84 with you when looking at this slide. Okay, X bar is equal to 22. That was given. Now we have to compute or determine S, and that was also given. It was given to be 2.5. And this is the note that I have at the bottom is just what I described, that sometimes you might be given the data values and you have to actually compute X bar and SX. So moving along, the next step, which is the heavy set, these are the heavy steps. Compute the standard error. And to compute the standard error, the formula is Sx divided by the square root of n. So it's not the standard deviation, but it's a standard error, and it uses the standard deviation of the sample divided by the square root of n. So we're going to plug that in for the values that we have. The standard deviation was 2.5 and n was 50. So that's going to give us a 0.35353. I want you to write that down. 0.35355. Okay, now we're ready to find the critical value, T star. So the T star is the area, the T value corresponding to an area to the right of alpha over 2. So we can do that by using the inverse T, and the argument that you would give it is 1 minus alpha over 2, or you can go to the other side, in which case you would use minus inverse T of alpha over 2, because you want to be on the right side. Okay, remember with this function, you need to give it the degrees of freedom. The degrees of freedom is n minus 1. So you think of the degrees of freedom as tables numbered 1 less. So if you're looking for the table for n equals to 24, you would have to use the table n23. So the degrees of freedom here is n minus 1, so we have to substitute n minus 1 as 49. So you plug that in and you will get 2.00957. So those two values I want you to write down, 2.00957. Moving on. Now remember those two values that I asked you to write down. Those come over to the next step. And the next step is to compute the margin of error. Margin of error is denoted by the letter E. So E in general is T star times SE. And those are the two numbers that I just asked you to write down. So E is equal to 2.00957 times 0.353505. Notice I'm always working in 5 places of decimal. The reason is, most of the time, they will ask you for an answer to 4 places of decimal. If you want to give an answer in 4 places of decimal, you have to work in 5 places of decimal all of the time, not some of the time, all of the time. Then you would round at the very end, okay? So now we're in a position to find the confidence interval. The confidence interval is simply to subtract e from x bar. So x bar is sitting in the middle, and add e to x bar. So here we go. We're going to subtract the 0.71048 from 22 and add likewise to 22. So we get our confidence interval, the left endpoint and the right endpoint. Don't forget, sometimes they may ask you to write the confidence interval the other way, which is x bar plus or minus e. So what would that look like with the numbers? It would look like 22 plus or minus 0.71 if you're going to two places of decimal. Notice that if they ask you for two places of decimal and you are using this notation, in other words, x bar plus or minus e, both numbers have to be to two places of decimal. Well, in this case, 22.00 is the same as 22 or 22 point or 22.0. So any one of those will suffice in this case. Okay, so moving on. In the second method, we're simply going to use the calculator function that was designed to calculate confidence intervals for means. So we just select that function, which is stat test, and it's the 8th one. So, and it's called 1 dash t interval. Okay, and it's going to ask you for the arguments. So all the arguments that you have, I have written down here as red. So the black is what you'll see on the calculator, and the red is what you would enter. So those that are within the little less than equal to, those are ones that you select. But other than those, you have to actually physically type them in. So the x bar, you have to type in 22. The sx, you have to type in 2.5, and so on. After all that, you will hit calculate, and this is what you would get as a result. So you would note it down, on your answer sheet, or if you're doing it online, those are the numbers that you would enter in. So our answer agrees with that which we get in the other method. Voila. Okay. So one thing we have to remember is how to interpret the meaning of the confidence interval. So a lot of times you'll get this question, give the interpretation, and here is the interpretation. We say that we are 95% confident that the true mean of, now that ... is because the example I gave you was simplistic, but really there is some real life situation going on in these problems. So you would have to say the true mean of whatever that true life situation is lies between 21.21, and you have to provide whatever the units are, if it was dollars or pounds or feet or inches, and 22.71, again, inches or miles, whatever the units are. Okay? So another thing is a sanity check. Whenever you calculate a confidence interval, you should find that the left endpoint is less than x bar, and the right one should be greater than x bar. As a matter of fact, it's sitting in the middle. X bar is sitting in the middle. So if you add them together and divide by 2, you should get x bar. Other than that, you have done something wrong. Okay? So I'm writing that down here. In fact, that x bar is in the center. So if you take the two endpoints and add them together and divide by 2, you should get x bar. Okay. So let's do another thing. We already did the confidence intervals for proportion, and now we did it for means. What is the difference? How do they compare? So let me do that in this slide before we go away. So on one side, I'm going to put for the method for confidence interval for proportion, and on the other side, we're going to do the same thing for mean. Of course, we're talking about for sigma unknown. When I go down this list, I would also mention if sigma is known, what happened. Okay, so if we're going to do confidence interval for proportion, you determine p hat and you determine q hat. Next, you will compute SE, and SE is equal to the square root of p hat q hat divided by n. Then you compute Z. So you see where we're heading with this? We're going to find E, right? So E is going to be the product of those two, right? And then so once we have E, you know how to compute the margin of error. It's going to be P hat plus or minus that E. On the right side, if this was for mean, instead of determining P hat and Q hat, there's no P hat and Q hat, it means it's X bar and S or SX. So you will find those two. Then you would compute SE, which is SX over the square root of N. Then you would compute the T value, the T critical value. So here is where, if sigma was known, you would compute a Z value. So the Z value would be just like the Z value on the left side for proportions, right? Similarly, the step before, if sigma was known, you wouldn't use Sx in that step. You would use S. Okay, so there are two differences right there. Those are the key differences right there for if sigma was known. If sigma was known, then that second step on the confidence for interval for means side would be would be sigma over square root of n. And instead of T star in the third step, it will be Z star. And it would be the same computation as on the left side. So now we're ready to find E, and that would be the T star minus the SE, and the confidence interval would be X bar plus or minus E, if we write it in that notation. You know, I choose to write it in that notation because if I use the other notation, it wouldn't fit. But I know you're smart, you know what to do. You know how to write a confidence interval in the interval notation. You can do that very easily. So that brings us to the end of this presentation. I would say if I went fast, sometimes I went a little fast, I believe. I even tripped myself up sometimes trying to talk so fast. Play the video again, slow it down, pause it, do whatever you have to do to make you understand. Appreciate it. See you again. Talk to you soon. Bye.